And let me just go back a second. Okay, now that we're recording here, we're going to finish up on section 10.3. You kind of started talking about ellipses yesterday, and we talked about the distance between any point on the ellipse has to be equal to 2a. Okay, so that's going to come back at some point. All right, for this first one here. So we got foci at 2, -3, and 2, 1, 2, 3, and 2, 5. 1, 2, 3, 4, 5. All right, and then we got a major axis of length 10. All right, that'll come into play here in a second. All right, what can we tell from here? From this information, what can we figure out? Josh?
The center.
Center, all right, good. Where's the center going to be at?
2, 1.
2, 1. It's got to be halfway between the two foci. Okay, so we can figure out the center. Now, in this case here, center is 2, 1. X minus h squared plus y minus k squared equals 1. Now, it's either going to be a squared or b squared here, or a squared or b squared here. A squared is always the bigger one. All right, do you know where the a, did I say that right? I said a squared is the bigger one, didn't I? Okay. All right, do you know where the a squared is going to go based upon this figure? Do you know where it's going to go? Is it going to go under the one on the left or the one on the right, or not sure?
I think it's going to go under the one on the right.
All right, good. What tells us that? You're correct.
It says that the length is 10 and the foci are like 8 apart, so I just kind of assumed that it would be like up and down right by the foci.
It has to be up and down because the foci are one on top of the other one. So this has to be a squared. This has to be b squared. Since the major axis, that is the entire length of the major axis, would be 10. So that means that, okay, you got to go 5 from the center, 5 from the center for that. All right, now, do I know A, B, or C at this point? Okay, what do I know?
A is 5.
A is 5, you're right. Since the major axis is length 10, that's 2. A is going to be 5. So that's going to be the distance from here to here. So A equals 5. We don't know B directly. We don't know B directly. I don't know how wide it is, but do we know C? Okay, do we know C? Tyler?
4.
C is 4. It's the distance from the center to one of the foci. So from right here to here, C is 4. So I know it's going to be some width at this point. Well, a squared equals what? Not a squared, C squared. C squared equals a squared minus b squared. Okay? Okay, not Pythagorean theorem, it's just a squared minus b squared. All right, now plug those in to figure out what your b value is. So c squared, which is 4 squared, equals 5 squared minus b squared. So 16 equals 25 minus b squared. Well, if I add b squared over here, I'm going to subtract 16. However you get there, b squared equals 9. B is going to be the square root of that. Now, technically, we don't need to find what b is for this one. I just need b squared, but it would be 3. So my final equation, since my center, what did I say my center was? 2, 1. X minus 2 quantity squared over b squared, which is 9, plus y minus 1 quantity squared over a squared, which is 25, equals 1. Always equals 1 for ellipse. It always equals 1 for an ellipse. All right, does that make sense? Okay, so that's what you need to do. Take that information. You got to pull out what A, B, and C are. All right, dude, take a look at the second one. If you need to draw it, that's fine. I know I didn't put a grid on there. See what you come up with, and I'm also going to ask you to find the coordinates of the foci. You can find the coordinates of the foci as well. I'll go through it if you get stuck. I'm just going to pause it here for a second. Let's see what you come up with. All right, minor axis length 2. So this deals with a smaller one number that's going to give us that b value. We're going to be able to determine the b value from that. All right, so for me, I'm going to at least plot these points. -1, 4. Okay, is right here, and then 7, 4, 1, 2, 3 is right here. All right, in the middle has to be what? Our center, right? So right there is going to be our center, which has to be 3, 4. From here, do I know A, B, or C? From information given, Aaron?
No B.
We know B. What is B?
B is 1.
B is going to be 1. Yes. All right. So right here, from the center, it says the minor axis has a length of 2. Okay. That is the whole axis. That is from one end to the other end. So actually B has to be half of that. So B will be 1. What else do we know? We should know something else. Cooper?
A is 4.
A is 4. A is the distance from the center to the vertices. And since they give us those vertices, A is as well 4, which means the total distance would be 8 if you want to talk about the major axis. But in this case here, so it's wider than it is tall. So it's got to be x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Well, what's we got our a and our b. Okay, so we can find the equation. So it's going to be x minus 3 squared. A squared is going to give me 16 plus y minus 4 quantity squared over 1 squared. Make sure you make that a 1 equals. And I did ask for the foci. Okay, so what's my c value? Tony, how do I find that?
You put a squared and b squared together.
And what's it give me?
15.
All right, make sure it's a squared minus b squared. You did it right. So 4 squared minus 1 squared, and we do get c equals the square root of 15. So your foci will be, all right, how do I write that? Okay, I guess you gotta watch how you write that. Josh?
That would be 3 plus radical 15, comma 4, and then 3 minus radical 15, comma 4.
Yes, you're going to start at that center point, 3 plus square root of 15 and 3 minus square root of 15, comma 4. That would be correct. All right, so that's everything, including the foci for that. All right, some of the applications that you've learned for a long time, when they talk about the orbits of a planet, they're going to be ellipses with the sun at one focus. Okay, Newton reasoned that comets moved in elliptical orbits as well around the sun. Calculate the distance traveled, okay, using that. And now there's a reflecting property. And here's how this reflecting property works. Here are your foci. Any wave that goes from one focus will bounce to the other one automatically. Okay. And so if it's a radio wave or if it's a light wave, it doesn't matter. It will always bounce to the other focus. And so there's what's called a whispering room, where if you are in one foci and you whisper something, you can hear it over here in the other one, like you're standing next to it. They have a room like that, I think, on your Washington, D.C. trip at the Capitol. They talk about one of those rooms like that. So it has a property because it's elliptical. I want to take a look at one problem here out of your book. I know we're out of room there. You can either finagle some room or just put it on a separate sheet. But turn to page 965. Let's look at number 74. Now I'm going to talk through it here in a second. But go ahead and read through it. Now this picture does not specifically apply to that problem, like the numbers don't apply to it, but I'll explain. This again is just demonstrating that reflective property. Now this is for a semi-ellipse. Okay, only half, but it's still your foci is gonna bounce. So think of that as a ceiling. So for 74, as you look at that one. All right, so they talk about the Whispering Gallery. The vertical cross-section of the dome of the Mormon Tabernacle in Salt Lake City, Utah is semi-elliptical in shape. So that would be this shape right here. Semi-elliptical, okay, from ground to ceiling. The cross-section is 250 feet long with a maximum height of 80. Where should two people stand to maximize the whispering effect? Okay, so we got this dome, which is semi-elliptical in shape. It is 250 feet long, and it is from floor to ceiling 80 feet high. What do we actually what do we need to find? Okay, for the to answer this problem, what do we need to find? Okay. Okay, you gotta find the foci. So think about that. So in order to find the foci, we need to know what A is, and we need to know what else? B. You know A. Now you got enough information to draw it out. There's just one easy mistake you can make. What does A equal? Okay, Josh? 125. What does B equal? B is the 80. Yep, make sure you don't cut that one in half. So A is from the center, okay, out. So A is 125. B is from the center up. It's going to be 80 because we're dealing with a semi half an ellipse. Okay, for the full ellipse, you would double that. Okay. So we would use those two values, and we know C squared equals A squared minus B squared. So C squared will equal 125 squared minus 80 squared. And then, what is that, 125 squared minus 80 squared. Okay, 9,225. I don't suppose that's going to be a whole number when I take the square root. 96.0. Let's just use 96.0. C equals 96.0. So how are you going to word your answer? You got to be careful how you word your answer. Where should two people stand? You should stand 96 feet from the center. You can say it that way. Or how far from the end point, end of the wall? So they should stand 96 feet from the center. Or if you're going to go from the end of the wall in, take 125 minus 96, what is that? 29? Or 29 feet. Or 29 feet from the end. Or from the wall, I should say. So that is the whispering effect of an ellipse. Okay, you got a little bit of time here. Get this done, or get as much done as you can. Corrections, if you need questions, if you have questions on those test corrections, you weren't quite sure what you did wrong, or you need some explanation, now is a good time. Finish those for Monday. And if you want to turn your test in, you're good to go. I'll take that here in about 5 minutes. I'll be around. I'm going to finish up